All right, let's dive right in. We're going to pull back the curtain on one of the most ancient and honestly amazing food transformations out there. We're going to uncover the science of how one single, simple ingredient, milk, can become thousands of different kinds of cheese.
I mean, just think about it for a second. You've been there, standing in the grocery store, looking at that wall of cheese. You've got your hard ones, your soft ones, crumbly, creamy. It's kind of mind-blowing. How on earth does all of that come from just milk? It seems impossible, right? And yeah, it feels like magic. But the real answer? It's way more fascinating. It's pure science. It's a precise dance of microbiology and chemistry that humans have been perfecting for centuries. And we're about to break down exactly how it all works.
So, to really get how the transformation happens, we've got to start with the raw material itself. We've got to understand the milk. Okay, the absolute star of this whole show is protein. But here's the thing. Not all milk protein is the same. About 80% of it is something called casein. This stuff is our hero. It's basically the structural skeleton that's going to become our cheese. The other 20%? That's whey protein. It's good stuff for sure, but it's water-soluble, which means most of it just washes away with the liquid. But casein doesn't fly solo. A great cheesemaker is like a conductor, and they're directing a whole orchestra of components. You've got the protein, which we said is the structure. Then you have fat, and that's the flavor engine. That's where all the richness and creaminess comes from. Then there's lactose, that's just milk sugar, and it acts as the fuel for all the microscopic helpers we're about to meet. And finally, you've got minerals. Think of them as the superglue that's going to hold this whole thing together. All right, so we have our ingredients. How do we actually put them to work? Well, that brings us to the cheesemaker's secret toolkit, where we start turning those passive ingredients into something totally new. The very first tool in the kit is completely invisible. We're talking about starter cultures. Now don't worry, these are the good guys, specialized bacteria that have a very simple but very critical job. They eat the lactose, that milk sugar, and as they digest it, they basically produce lactic acid. This makes the milk more acidic, lowering its pH, which not only protects it from bad bacteria, but also gets it ready for the most important step of all.
Because once that milk is acidified, the cheesemaker hits a fork in the road, and this is it. This is the first and maybe the most important decision they have to make. This single choice will determine the entire destiny of the cheese.
So here are the two paths. On one side, you can just let the acid keep building up. Eventually, it makes those casein proteins stick together into a soft, really fragile curd. This is great for fresh cheeses, like cream cheese or Chev. But for almost everything else, you need path number 2, enzymatic coagulation. This is where you add something called rennet. Think of rennet as a bunch of tiny molecular scissors that snip the casein proteins in just the right way so they can link up and form this strong, rubbery, elastic net. This is the only way you get a curd that's strong enough to be pressed and aged. Okay, enough with the theory. Let's see how this all plays out in the real world. We're going to follow the journey of 4 totally different cheeses and see how these small tweaks in the process lead to wildly different results. And first up is a global superstar, a cheese everyone knows: cheddar. The secret to cheddar, its whole identity, is forged by one single thing: pressure.
So after the curds are formed and cooked and the whey is drained off, you get to the signature move. It's a step that's so important, it's literally called cheddaring. You take these big, warm slabs of curd and you stack them on top of each other. Their own weight presses out even more whey, creating that dense, kind of crumbly, firm texture we all know. It's like a workout for cheese. After that, they're milled up, salted, and then pressed under even more pressure before they're put away to age. Okay, so we've gone from pressure to plasticity. Our next journey is with the cheese that basically defines pizza night: mozzarella. And its whole secret is the art of the stretch. Now, for mozzarella, the chemistry has to be perfect. You have to hit the super precise acidity target, a pH of about 5.2. Not 5.1, not 5.3, exactly 5.2. Because at that exact moment, the curd's protein structure becomes unlocked. You drop it into hot water, and suddenly it's like hot taffy. The cheesemaker can then knead it and stretch it over and over. And that stretching, you're literally lining up all those casein proteins into long, parallel fibers. That's your cheese pull. It's not magic, it's just perfectly aligned protein strands. All right, let's switch gears completely.
from firm and stretchy to soft and gooey. Let's talk about Brie, the king of soft cheeses with that beautiful, fluffy white rind. This is all about the art of the bloom. For Brie, the cheesemaker adds a special white mold, Penicillium candidum, right into the milk. This little guy sets up shop on the outside of the cheese, creating that bloomy rind. But it's not just sitting there looking pretty. It's working. It's releasing enzymes that slowly seep into the cheese, breaking down the proteins and fats and turning them into that ooey, gooey, creamy layer. It's actually ripening the cheese from the outside in. That's why a perfect Brie is always creamiest right under the rind and a little firmer in the very center. And for our final case study, we're going bold. We're talking about the pungent, powerful, and instantly recognizable blue cheese. And its creation, well, it's all about giving it a little room to breathe. So this time, the special mold, Penicillium roqueforti, is mixed right into the milk. But there's a catch. This mold is aerobic. It needs oxygen to grow. And inside a dense wheel of cheese, there's no air. So what do? You let the cheese form, and then you bring out the needles. You literally pierce the wheel with long steel needles all over. This creates tiny channels that let air deep inside. It's like a wake-up call for the dormant mold. It springs to life and starts to grow along those new pathways, creating those signature blue-green veins and that sharp, tangy flavor. So let's just put this all together for a second. It's incredible. 4 cheeses, all from milk. But cheddar is all about that squeezing and pressing. Mozzarella is about hitting that perfect pH and then stretching. Brie gets its creaminess from a mold working on the outside. And blue cheese needs to be pierced so a different mold can breathe on the inside. It just goes to show how 1 or 2 different steps can create something completely new. Okay, we've covered the science, but there's another side to this story. Let's talk about something you've probably noticed at the store, the price. Why do some cheeses cost so much more than others? It all comes down to the cheesemaker's equation, and the answer boils down to one critical idea: cheese yield. It's a simple concept, really. It's just how much cheese you get out for the amount of milk you put in. And the number one factor that determines yield is moisture. Plain and simple, how much water is left in the final cheese.
And when you look at the actual numbers, it's pretty staggering. To get 1 kilogram of a soft, wet cheese like Brie, you need about 7 kilograms of milk. Okay, not too bad. For a harder cheese like cheddar, that number jumps to 10 kilos of milk. But for a super dry, long-aged cheese like Parmesan, it takes a massive 15 kilograms of milk to get just 1 single kilogram of cheese. So a huge part of that price tag you see is just milk. You're paying for all the milk that it took to make that dense, dry, delicious final product. So we've touched on the chemistry, the microbiology, and even the economics. Let's just zoom out for a final thought and appreciate the big picture here, the true art of this transformation. You know, we hear that word terroir a lot with wine, talking about the soil and the climate, but with cheese, it goes so much deeper. The true terroir isn't just what the cow or goat ate. It's the invisible world, the unique community of microbes that live in that specific barn, in that specific dairy, in those specific aging caves. They are the final secret artists. They add layers of flavor that you just can't replicate anywhere else on Earth. So the next time you enjoy a piece of cheese, remember that incredible scientific journey and that invisible world that turns simple milk into something truly special.